Well, good day all, and I hope you're enjoying the Prescribed Fire Workshop. We're going to talk about fire weather and other important considerations, and so we'll just go ahead and get right into it. My name's Hugh Scanlon. I'm retired from CAL FIRE. I've had many jobs when I was with CAL FIRE. I was the unit chief of the Humboldt-Delta Nord unit by the end of my career, but for a while there I was the Prescribed Fire Manager for the North Coast. I was a qualified fire behavior analyst. And I teach wildland fire behavior both at the national level and I've taught at Humboldt State University. So let's talk about fire weather and how that may apply to what you're doing with planning for prescribed fire on the landscape. So why do we even care about fire weather? Well, fire weather really can make the big difference into whether your burn is going to be successful or not. You got to think about the burn objectives, what it is you're trying to accomplish with your burn, and what are the best ways to achieve them. And the weather really ties into that. So if you've got conditions that are too cool, where the burn may not go quite the way you want to, you can end up with a bit of a mess where you end up getting maybe part of your control lines burned in, but maybe not all of them. And that can lead to all kinds of problems. Conversely, when you have conditions that are too hot, the fire can be way too aggressive, and that can create a completely different kind of mess with your fire potentially getting outside your control lines and causing all kinds of havoc on the landscape. So you really want to think about how the weather is going to tie into what you're trying to burn and how those weather parameters can help you in designing your burn so it's just right result. So what are you burning? The main thing that carries fire is the fine dead fuels, the fine dead material. And so we talk about fine dead fuels. Think of cured grasses, dead litter material that's on the surface. These are the primary things which will carry fire. And the relative humidity, temperature, and wind really have a big influence on fuel moisture. And so they can be big factors in changing how your fuel moisture changes. And look, fuel moisture is important. The lower your fuel moisture, that will promote combustion. Higher fuel moistures, what happens is the moisture that's in that fuel, the fire needs to cook that moisture off before that fuel will actively be consumed. So it slows down the combustion rates. So the fuel moisture is really important. And so the one thing that is really a strong thing to consider is what your fine fuel moisture is going to end up being, what targets you want to have for your fine dead fuel moisture, because that can help you determine many times what kind of rates of spread, flame lengths, and other critical factors that can come in when you're planning your burns. So relative humidity and temperature, these are big factors. Relative humidity is a measure of moisture in the air, and fine dead fuels, and those are the sizes 1/4 inch and smaller, they respond really quickly to changes in relative humidity. And we consider them to be a 1 hour fuel because they will change in 1 hour or less. So relative humidity, as it goes down, things are drier. So the fuel dries out and makes it so it's more readily burnable. Conversely, when your humidity goes up, it increases the amount of moisture in your fuel, the amount of burning that the fuel can do. It slows down the burn rate, and so that will slow your burning. And temperature is also important, but largely because of how it affects relative humidity. As the temperature increases, if you think back to Boyle's laws, temperature increases and pressures remain the same. What ends up happening is the amount of moisture that the air can hold actually increases. But if you have the same amount of moisture that was there before, an increasing temperature actually lowers your relative humidity. That's why you see humidities tend to lower through the day with the same relative amount of moisture in the air. So this is a big factor. Temperature increasing will lower your relative humidity. And at the end of the day, as the temperatures decline, your humidities start to rise again. And so both temperature and relative humidity are factors that are used in calculating the fine dead fuel moisture values, and they are key factors in doing that. We'll talk about that a little bit more. Winds are a big deal. They're a critical aspect of burning, and they increase the rate of moisture exchange in your fuels to some extent. But that's not really the main way that they can end up influencing your fire. It's that the winds themselves help drive the fire behavior, the direction the fire's going, how much oxygen is really being supplied into that burnt, that area of combustion. And so the winds can tend to be a pretty big factor in how your fire ends up burning and the direction your fire wants to go. But how we talk about winds is really important. There are a lot of different types of wind measurements that are used out there. First one we'll talk about is a 20-foot wind, and that's a surface wind. This is what you get in a fire weather forecast, and it's a standard. It is the wind that's 20 feet above the height of the vegetation. So 20 feet above the height of the vegetation is a big deal. Is that 25 feet above the height of grass? Is it 20 feet above the height of brush, or 20 feet above the height of timber? And certainly in timber stands, 20 feet above the height is pretty high up in the relatively speaking, above the ground. So this 20-foot wind is really important, and it's the primary wind that they'll talk about is being a surface wind. The next kind of wind we want to talk about is an eye level wind. This is what affects the fire. Eye level is about the same height as the flame height of the fire. So this is the one that's actually influencing the burning fire front. And vegetation and terrain have a huge impact on how much wind is affecting the fire front. So if you think about the terms of the 20-foot wind, the surface wind, and you bring it down, the vegetation has a big difference. If it's grass, it will reduce the effective wind speed at that eye level to about half of what it was when it was surface wind, the 20-foot wind. If it's brush, it reduces it down to about a quarter. And for timber, it's 10 to 20%. It can even be less than that, depending on how low that wind is relative to, or how high that wind is relative to where your fire front is. So it can make a huge difference. And so this is important because when you start talking about forecasts, and if you request a weather forecast, you want the 20-foot wind, then you can estimate what it's going to do in your fuel type as the wind changes going through either over that type of fuel or you get transitions between different fuel types. Slope position is also important. Higher points on the slope may be more exposed. Depends on a lot of different factors, which direction the wind's coming from. But really, the main thing to be thinking about is how this wind is going to end up affecting the fire front right where you're burning. And don't expect the meteorologist that's doing the weather for you to have to guesstimate how it's going to interact with that vegetation. That's something you want to be thinking about as you consider the vegetation you're working with. And so weather and when you are burning is a big factor too, because burning, the timing of your burning is very much weather dependent. Forecast can help you pick potential good burn opportunities. A lot of burn opportunities are missed because there's a lot of different things going on and you don't really see that burn window coming, and it takes time to prepare for it. So if you can look at what a forecast is showing for your area, that can really help you anticipate the conditions that you may need a couple of days out to be ready to do your burns. The next thing to be aware of is weather warnings and other kinds of watch outs. Red flag warnings are posted when the Weather Service is seeing that collection of critical weather that promotes large fire spreads. And when you get those days starting to come, it changes a lot of factors. Many times in trying to get a burn permit, you may be limited in being able to burn during red flag warnings. You may very well have extreme difficulty controlling fires during the red flag conditions. So you want to be very careful if you're looking at trying to burn in those periods. Plus, it also affects the resource availability. And that is what you have available for burning to help you burn and to control the fire that you're putting on the ground. But it's also a very critical factor in what your agencies have available, whether it's CAL FIRE, the Forest Service, or your local fire departments trying to help you out. When you get red flag conditions, it really limits what they can do because they may be committed to working other fires in other locations and responding to fires and emergencies in other areas. So you really want to avoid even trying to put a burn together when you've got fire weather watches or red flag warnings being posted for areas that you're trying to burn in or maybe immediately adjacent to where you're trying to burn. They can certainly cause issues for that. So burn planning is kind of the thing where you're trying to figure out what's going to get you the best results, what your objectives are, how you're going to try to get your objectives achieved in that area. And so the key tools that I like to look at are the fine dead fuel moistures, probability of ignition, and we'll talk about the fire characteristics chart. It's also called the hauling chart. And then we're also going to talk about smoke management because smoke management is a really big deal. If a good planning can help you avoid having adverse smoke impacts. So let's talk about fine dead fuel moisture. With fine dead fuel moisture, you have a number of different kinds of fuel types and different ranges of fuel moisture that are available to that the fire will burn through. So in these graphs, I'm showing a head fire, that's the graph on the left, and a backing fire graph on the right. The curves in each of those are for different kinds of fuel models. Curve number 1 is in red and it's for grass model. Curve 4 is a brush model and curve 10 is a timber model. And then across the bottom, you'll see the 1 hour fuel moistures in percent. And this is really a critical thing to watch because you can see that in your grass model, as your fuel moisture approaches 12%, your rate of spread and your flame lengths drop to 0. And so if you're trying to burn when you have a fine dead fuel moisture of 14% in grass, the fire is not going to want to carry it all. It's just, it may sit there, it may burn, it may smolder a little bit, but it's not going to carry. You need to have some ability for the fire to carry through the fuels that you're looking at. And you can see that grass is by far the most responsive to the changes in fine dead fuel moisture, but you can also tell whether it's in brush or in timber that the moisture value is relevant to how that fire is going to want to burn in that particular fuel type. And so I've got illustrated here again a head fire on the left side and backing fire on the right, and these are the surface rate of spread. So this is how fast the fire is moving through, and you want to make sure that your fire has the ability to move through the fuel at a reasonable pace for what you're trying to do. So you may determine that, okay, if it's moving at 10 feet a minute or less, that may not be okay for fire moving in grass. But you may look at trying to burn in drier conditions, lower fuel moistures in those kinds of situations. But this is looking at both the head fire and backing fire rates of spread. And rates of spread don't tend to be the critical thing that we look at, but it's important to note when my fire is not really going to want to burn. And that's certainly here for grass, you're looking at, you got to get to about 11 or 12% fuel moisture or higher. You're not going to get very good burn results. The next one we're going to look at is surface fire flame length. So this is the flame length of the burning front. And again, on the left is a head fire, right is a backing fire. And you can still see the same thing with grass at 12%. The fire essentially goes out. Your surface flame lengths go to 0. However, as you come away from that and you get drier and drier and drier conditions, you'll see that whether it's a head fire or a backing fire for brush or for grass, you know, flame lengths of 4 feet with a 2% fuel moisture for a head fire. You know, that's a pretty good piece of fire that's on the ground there, and those are really dry conditions. And you can tell also that the timber model is not that much different, other than it'll burn to even moister fine dead fuel conditions. The place where you see some real challenges, though, is when you look at what's going on with your brush model. And the brush model surface flame lengths are ranging from 17 feet down to 12 feet, and 12 foot is with a head fire at 14% fuel moisture. Backing fire, on the other hand, you'll see that's on a slightly different scale. At 2%, it may be a 6.5 foot flame length, and that will come down to a 4.5 foot flame length as a backing fire with at 14%. So it's important to note there's a difference in the flame lengths that you expect from a head fire to a backing fire. And that influences a lot of the things that we decide to do on how we want to burn a given area. If we're broadcast burning an area, we're usually looking at going to the top end, the direction the fire is going to tend to want to burn, and then igniting along the control lines there to create a backing fire. And that backing fire will back down to build some depth of burned area that will allow you to safely conduct the balance of your burn as you get your burn areas burnt in from the lines towards the middle. And in most cases, we'll use backing fire for that. And you can see that if you were to use a head fire in a lot of these conditions, the flame lengths would be pretty big. And so that's why we tend to favor backing fires. This is important as we go on, because we'll talk about the fire characteristics chart. So flame length. On the right side of the chart, you'll see flame length in feet, and you see 4, 8, 11, and 15 feet. And each one of these is relevant to how successful we are in trying to control fires that have these characteristics. You can see 4 foot, if you go all the way over onto the left side of the chart, you see a guy down there with a hand tool. Generally 4 foot and less, hand tools, people using hand tools can usually work those fires pretty successfully. Once you get between 4 and 8 feet, you'll see that there's a bulldozer in there, and you need heavier equipment or fire engines to kind of work in those areas. And if you remember from what we had before with the brush, you'll see that the brush, you know, your backing fires are above 4 feet in length. So you really need to start thinking, well, if I'm burning brush, what kind of equipment do I have available to be able to assist me with those burns? So 4 foot to 8 foot, you're needing fire engines or heavy equipment like bulldozers. Then you get above 8 feet. 8 to 11, you'll see trees are torching out significantly. You can start to have some pretty significant fire spread from crown fires. And then above 11 feet, you get your big bad fire at that location, at those kinds of conditions where you get that. And if you noticed in the brush models, in dry conditions in the brush, we definitely had areas where we would exceed 11 foot in flame lengths. We were exceeding 11 foot flame lengths with head fire at 14% fine dead fuel moisture. So you definitely need to think about backing fires and building depth with a backing fire when you're talking about working in brush areas. So this is referred to as the fire characteristics chart or the hauling chart. It tells you where you can use tools, where you need to be using equipment, and where you need to start thinking about hauling yourself out of there. So this is a fire characteristics chart, again, helpful in understanding how you're going to go in and do your burning.